Okay. So this past week and in the lab on Friday, we've been talking about static methods and writing static methods and how you can use static methods to make it so you don't have to write your entire program within the main method of your Java class. And today we're going to be going over what actually happens when you pass parameters into those static methods and how Java treats the memory and all that good stuff. So when you call a method, how are the arguments connected to the formal parameters? And when the called method returns, how are the results communicated back to the code that called the method? So if you remember, oh, also I bought the new chalk. You guys ever see this chalk? It's like the Hagoromo chalk. You know what I mean? Yeah. So I'm really excited. Let's say we had, I think the example on the next slide is a public static int. Okay, it's not that good. Public static int GCD int I int. Yeah. So we have this function, this static method called GCD, whose purpose is to compute the greatest common denominator between two integers I and j. So these I and j are what's known as the formal parameters. And if you remember back to last week when we were talking about how when you're writing methods and you're implementing them, there's a contract between the implementer, whoever's writing this method, and then the client, whoever's actually going to be calling this method, or the caller and the callee. So if I'm implementing this method, the formal parameter is a way for me to talk to the client and basically say, hey, in order for me to write this cool greatest common denominator function that you want me to write, I'm going to need two integers that I can use to compute the greatest common denominator between them. If I was not passed two integers, then I, as the implementer, would have basically no idea like what I'm supposed to compute the greatest common denominator between. So formal parameters are the responsibility of the client to include in the method header so that when the client or the person that's using the greatest common denominator method calls the function, they know what they have to input. All right, cool. On the client side, oh, wait, no, I lied. This is the implementer. Ignore what I just said. So implementer is in charge of defining the formal parameters. The client is in charge of providing the arguments. So the arguments are when I, the client, decide that I want to call this greatest common denominator, I'll switch, greatest common denominator method, I must provide it two integers in order to compute the greatest common denominator. That's part of the contract between me and the implementer that basically says, hey, I'm using this greatest common denominator method. The contract specifies that I need to provide it with two integers, so I need to provide it with two integers. And you can see here an example of how this would be called. So GCD 24 and was it 80? So the greatest common denominator between those two is 8. These, oh, that's terrible curly brace, would be the arguments. So when you are writing Java code and you're calling upon static methods that you have written or potentially somebody else has written that you are using, you're in charge of providing the arguments to the code. We all good on that? Cool. Okay, so let's just say that the GCD starts with an integer k, somehow computes the greatest common denominator, and then returns k. And then somewhere else in the code, we define two integers a, b, and then we define an integer c, which is going to be the result of the greatest common denominator between a and b. So how does this actually play out in the Java code? So you remember when we were talking about defining integers and defining values in Java, I like to think of it like Java has like a little warehouse that stores all of your variables. So that's the comparison we're going to run with today. So when we define, we get to this part of the code, int a, b. What we're doing is we're saying, hey, Java, in memory, reserve two locations for me, an integer called A, put his name down here, and an integer called B. So make two little boxes in my warehouse that contain values for A and B. They're going to be integers, and as you can see, because we did not set them equal to each other, we did not set them equal to anything, their values are currently unknowns. And then we say we want an integer C, which is equal to the greatest common denominator of A and B. But I think we have more to do first. Yeah. So this is the method greatest common denominator that is being called. I and J are the formal parameters, which again, formal parameters, implementer, client, arguments. This is called the arguments. They are the arguments of the call of greatest common denominator. All right, so suppose the solid red arrow indicates where program flow of control has taken us thus far. So maybe you have a bunch of code before this. Maybe this is the first thing that you're writing. Either way, after you run int A and B, just like up there, we have our two boxes in our little Java warehouse that are going to potentially store values. Now, let's say somewhere in the rest of the code, it's not shown here, is we set A equal to 24 and B equal to 80. So we open up our boxes and we say, hey, I want this to be equal to 24. I want this to be equal to 80. Cool. So now we have two variables, A and B. And then now let's say we call this GCD method that has been implemented. For the purposes of today, just assume that this works for everyone. So we say int C equals GCD of A and B. And since we have our variables, this is quite literally the same exact thing as calling GCD 24 and 80. Because our variables are integer literals, Java can treat them as such, and this is essentially the same as passing in 24 and 80 to the program, which will become important later. And then we're saying compute this value, and whatever gets returned from this value, store it in the integer C. So I think the bottom had a return K. Yep, return K. Okay. So now that we've called the greatest common denominator method, let's say we just are running this line of code here. Java's going to go up to our static int method, greatest common denominator, and it's going to say, okay, in order to use this method, we need two integers, I and integer j. The crux of today's lecture and formal parameters in general is that these integers I and j are not the same as the integers a and b. So we make two separate boxes in our warehouse called I and j, and they're also integers. Granted, these are not the same as our integers a and b. So the formal parameters are effectively declared. The big crux is that whatever you pass into the method as arguments are going to be copied to these values, integer a and integer I and integer j. So it's done based on what order they're placed in. So since we passed in a and b, a is going to get copied into I, b is going to get copied into j. So what that looks like is we say, hey, Java, now this integer I, store it with the value of a. And since the value of a is 24, then the value of I is going to be 24. And since the value of b is 80, the value of j is also going to be 80. That's like the aha moment of this entire lecture, is that for primitive types like integers and doubles and booleans, these values are simply copied into new memory locations that Java stores for you. Strings are a whole other can of worm that we get into, I think, later in the semester. Okay. This is just saying that when you call this method, code does not continue going on. Like if we had a print statement after this, it waits until this function is done computing in order to move on with the program. So let's say this function had an infinite loop in it. we called this method, the program would just never continue on because it's stuck trying to figure out how to finish this greatest common denominator function. And control is transferred to the beginning of the method body. You can really think of it like if you have a bunch of code, like you have a bunch of code here, and then you have this call to GCD. What this is doing is it's just copying all of the code in here and just like pasting it right below where it is, except it's packaging all that code up into a single call so that it keeps your code clean and concise. So control is transferred to the beginning of the method body. And the scope of these variables is the calling program where they are declared. Okay, so I think we talked a little bit about scope again, but let's get into it. The scope of your variables is going to depend basically on what level of curly braces you are at. So if you define a function in your main method, the scope of those variables, so let's say that these integers a and b were defined within the main method. The scope of those variables is only going to be within the main method. So if you have a main method and you call the GCD function, and then all of a sudden you try to say print a, it's going to yell at you because it doesn't know what a is. The scope of greatest common denominator is only what's defined as the formal parameters and anything you make within the static method. So any variables that you declared outside of the static method in the main program or even in another static method are going to be different. As an example, let's say we had another public static and yada, 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 whatever the method name is. And we defined an integer a here. And then we defined, say, an integer a here. These two a's are completely different boxes within Java's memory. And we're allowed to do that because the scope of these two methods is different. This a is different than this a. And both of these a's are different than, say, the a that we declared in the main method. The scope of any of your variables is only going to be within the method that it was declared in. Does that make sense? Cool. Scope of the variables is the calling program where they are declared. Yeah, so the scope of these variables in the method body are also where they are declared. So these formal parameters take on the scope of the method that they're in. So you can use int I and int j in this program. Let's say you wanted to print I. I'm using print instead of out.println because it's pedantic. What this does is it's going to go and look in the value of whatever the variable is stored at I, which in this case is 24. You're allowed to do this. As soon as this method body terminates, Java has something called the garbage collector, which sounds pretty cool. And essentially it says, hey, these variables is anyone like using them or have we used these or are we using them? And since this method has if this method has completed its execution, Java says, no, we're not using these variables anymore. Kill them, like don't use them anymore. And the garbage collector will erase them. This is something very cool that Java does. Yeah. I think it might. I think the termination of a static method might call the Java garbage collector to go through and then just delete any temporary variables. Programming languages such as C, I know C is the one that is the big one here, but you actually have to allocate memory for your variables yourself. So you have to say, hey, I want to allocate memory for an integer. And then if you forget to deallocate that memory, you get a bunch of errors and it's really annoying. So it's really cool that Java does this. This is why on Friday, some of you guys had errors where you were trying to use variables from your static method in your main program, and it was giving you errors because the scope of those variables was only within the static method. It was not within the main program. A good rule of thumb is that variables are only contained within the curly braces of which they are defined in. So if you define a integer or a string in a main method, you're not really allowed to use it in a static method. And if you have a formal parameter I or j, you're not allowed to use it in the main method. Okay, yada, yada, yada. Let's say it computes the greatest common denominator. And let's say after this is done, the values of I, j, and this new variable k are whatever the values they say it are. So 8, looks like I is 0 and j is 8. Okay, so this is a completed greatest common denominator function. Think back to tracing tables. This would be the mathematical representation of all the variables that are currently existing. So as of right now, our Java warehouse looks like this. In our main method, we have a warehouse that has integers a and b with values 24 and 80. And in our static method GCD warehouse, we have 3 integers, I, j, and k, which are 0, 8, and 8. Notice how throughout the GCD method, the values of j and k were changed, but the values of a and b were not. So that goes back to the whole crux of the thing, which is that these values are copied in. They are not the same. I is not j, or I is not a, j is not b. Their values are the same at the beginning of the function call, but that does not necessarily mean that that is true at the end of the function call. That's like a big thing to like put it like a star next to that if you're taking notes. Okay, so we have I, j, and k. The last line in our function is return k. If you remember back, because we declared this as an int method, this is the return type. I don't think I have space up there. Which means that as the implementer, it's up to me to return an integer at the end of this function. So we're saying we're going to return the value of k. What's the value of k? Value of k is 8. So what happens now? The return statement immediately ends execution of the method body, and the return value is copied back into the calling program. So what this is an expression. You guys remember expressions? This expresses to 8. So Java says, hey, I computed that GCD function for you. The value's 8. And we say, cool. Now, if you, let me cover it up here. If you did not have this int c equals, Java would say, all right, the GCD is 8. And you wouldn't do anything with it. So you would not have any idea what that value is. Setting it equal to 8 tells Java, hey, that value that was returned by the GCD function, store it in an integer c. Oh, I'm running out of space. Here's c. Store that value within this integer, 8. And this also works for printing. So let's say instead of int c equals GCD AB, you did out.println GCD AB. The expression would return 8, and so Java would just treat that like you're trying to print out an integer, and it would print out 8 to the console. And also you can do it with formal parameters. This is pretty stupid, but you could say, I want to compute the greatest common denominator, and I want to pass in as my argument the greatest common denominator of 2 other numbers. And for the second argument, I want to pass in the greatest common denominator of 2 other numbers. What will happen is Java will evaluate your 2 inside greatest common denominator values, and then it will just copy those values as the arguments and then compute the greatest common denominator of those 2 values. So it's important that you actually do something with the value that the code returns. All right, and the method body is finished, so the variables go away. This is another important thing. After this method body is done, Java has like a big garbage collector, which you can think of like an eraser. Kind of like goes in and says, these are no longer needed by the code, so we're going to get rid of them. So all that's left is your original values of A and B, which have not changed because their values were copied, and then the return value C, which is the integer 8. All right, note that the values of the formal parameters are not copied back to the arguments. Execution of the calling program resumes in mid-statement. So now we've got this value that's returned here, 8. and it gets assigned to the integer c. And that's the crux of it all, is formal parameters. Does that make sense? Is there anything that you guys want me to go over, or any questions you guys have about that? Going once, going twice. Sold to slide 27, which is when you call a method, how are the arguments connected to the formal parameters? So that's the question that was posed at the beginning of the class. The answer is that the argument values are copied into the formal parameters in order to initialize them. So again, formal parameters, implementer is in charge of defining them. Client is in charge of providing the arguments. And the formal parameters, or the arguments, are copied into the formal parameters. And then when the called method body returns, how are the results communicated back to the code? Only the return value is copied back to the caller. The formal parameters are simply lost. They're temporary variables that only really existed to serve the purpose of computing the greatest common denominator. So they're garbage collected. Rest in peace, I and J. Now, if you called it again, same process would go over again. It would declare new boxes for I and J, compute new boxes for everything, calculate everything, return everything, and then Java would once again come through and just wipe it out. Okay, names for this. Parameter passing mechanism of Java. So what we just talked about is called call by copying, because as you can imagine, the argument values are copied into the formal parameters. It also can be termed call by value, because the argument values are copied into formal parameters. There are other ways it might have been done and is done in some languages. When you get to C, you do this really annoying thing where you have to have pointers to the boxes in memory instead of just actually calling the variable names, and it's like super annoying. But that's not until like systems 1, so you guys have like a year for that. So just don't think about it. Later in the class, we'll talk about call by reference. This idea of copying the values into the formal parameters only works for primitive types. So if you were making a method and you wanted to pass a string is the most pertinent example here. Strings are what is known as call by reference. So instead of passing the value of, say, an integer A or an integer B into the formal parameters, it copies a reference. So let's say these integers were strings instead of integers. The value of I and J wouldn't be values. They would be pointers that pointed to A and B. So if within whatever method these are called, you modified I and J, they actually do modify the original values that are outside of the method. But that's not till later. So we'll get into that fun stuff later. Okay. And then if you wanted a tracing table representation of everything that we just did for some reason, here it is. A and B before and after are unchanged. That's the crux of it all. When you're using pass by value, the arguments are copied into the formal parameters for you to use however you please, and then afterwards they are the exact same. Yeah. It's just an example function, which is the greatest common denominator.
So it can't, if I type GCD, it won't happen.
No, because it was a static method that we defined. I'm sure the math package has one, but let's say there was a project that asked you to implement the GCD. This is how you would do it, is you'd make your own static method. Okay. We're not done yet. Next up, we're going to completely switch gears and we're going to talk about arrays, which are also pretty sick. I'm going to be honest, this chalk that I ordered does not erase well at all.
But it's quieter than the last one.
Huh?
It's quieter than the last one.
Yeah, well, the the squeaky chalk only came from when I tried to use that weird like pen thing. And I think it was like, I don't think I was using it right. In any case, moving on to arrays. Any questions about anything, by the way?
Why is our first midterm on September 19th? Like,
I don't make the rules, man.
is that just like what the higher ups decided?
Yeah. So basically every night I receive a vision and it's Paolo Bucci in God form and he tells me what to talk about the next day. He says the midterm is September 19th.
Okay,
I
well,
go, okay.
I'll think of you about that in a couple weeks. It's okay.
Yeah. But the first midterm, yeah, it'll be fine. We'll talk about it. Okay. So an array is a new type of variable or a new type of they're called collections in Java. And it's a way to group similar variables, all of the same type, with systematically related names that involve a special syntax. So to motivate the idea of array, you can imagine that, let's say you were programming Carmen from the ground up and you wanted to store everybody's grades. It would be really annoying if I had to say like int student A at like a 97% of the class. And then I had to say student B got like a 62 in the class. And I had to keep doing that for all, let's say 40 kids that are in the class. And then you had to multiply that by however many sections of software one there are, multiply that by like however many years you have to do it. Arrays are a way to group similar variables. So in this case, integers, in a way that is syntactically easy to reference all of the values of, in this case, student grades that we want. So you have an array, which is the collection of everything. You can think of an array like a filing cabinet in your little Java warehouse. And the elements of that filing cabinet are like the files contained within the filing cabinet. Only in this case, every single file needs to be of the exact same type. So they all need to be int files, or they all need to be string files, or they all need to be simple writer files. So you could have an array of like 30 simple writers if you wanted to do that for some reason. Each array element, e.g. a of 0 or a of 1, acts like a single variable of the type used in the declaration of the array. So each file contained within the filing cabinet or each integer contained within an integer array is its own separate integer, separate from all the other ones, and acts just like a normal integer would. So comparing this to mathematics, it is entirely parallel to the use of subscripted variables in mathematics. So if you have a vector of integers or a vector of floating point values, arrays are pretty much the same thing. Just as x sub 0 is pronounced x sub 0 in mathematics, a of 0, or I guess in this case, a sub 0 is what you would refer to it as. Other people also say like a of 0. Essentially just a way to reference the different values within your array. Similarly, you can have x sub I plus 2, and you can have a sub I plus 2. Just comparing to mathematics, if you guys are big vector fans in the crowd. Yep, so you can have a vector x of length n. In Java, the group of variables is called an array and it has a length of n. You'll notice that we start subscripting at 0. If any of you are coming from MATLAB, MATLAB starts subscripting at 1 because whoever programmed them must have been drunk. I'm going to be honest. Subscripting by 0 is far superior in you guys ever do like PowerPoint nights where like you like present a PowerPoint on like, anyways, I did like a 10-minute PowerPoint on why subscripting by 1 was the worst thing that anyone could ever do. So if you come from MATLAB, erase that from your brain, stop using MATLAB, and yeah, stop using MATLAB is honestly just a general like good tip in life. So you start subscripting by 0. That's everything. Okay, so declaring an array. Instead of doing all this, let's say that we wanted to make an array. They're going to call it int with, and they're going to call it A. I'm going to call it student grades. So how you signify to Java that you want to make it an array is that you add these little brackets here. These are like array's signature thing here is brackets. If you wanted to make a string array, it would be the same thing. Essentially, anything you want to make an array of, you add these brackets after. So what this does is it tells Java, hey, I'd like to make an array of integers called student grades. In this case, Java's kind of confused because it doesn't know how long to make the array. But how many? 4. Usually it's a very good idea to anytime you make an array to initialize it with a value or initialize it with a size or initialize it with values. I don't see a case where you would initialize an array that would be empty because as you'll see later, the length of the array cannot change. So let's say I made an array called 30 or called student grades and there was a size of 38. And then all of a sudden somebody added the class, I would have to make an entirely new array. And the reason for this is because of memory. And I think you get into it in Systems 1 again. Systems 1 is like the class where everything you take for granted about Java, they explain to you was programmed by somebody smart, and then they make you do it all yourself, and it sucks. But making an integer array, you can define it with a size by saying equals new int, and then in brackets 4. What this tells Java is, hey, I want to make an integer array called student grades, and I want it to have a size of 4. So what Java is going to do is it's going to make a filing cabinet. I'll draw it like this, with 4 different slots. When you initialize an array in Java, the values of these slots get initialized to some default value. So for strings, that'll be an empty string. For integers, it'll be 0. For doubles, it'll be 0.0. So what this does is it says, hey, we now have a filing cabinet of 4 integers that you can use as your integer array. And going back to the whole subscripting thing, a sub 0 is going to be here, because again, we start subscripting at 0 instead of 1. A sub 1 is here, a sub 2, and then a sub 3. Another important thing to note is that the length of the array. So there's a built-in method in Java you can use. Oh wait, this wouldn't be A, this would be student grades. I'm not going to write student grades 4 times. We're changing the name to A. I can see now why they made it A in the example. Okay, we have an integer array A, 4 values. Java has a built-in method called length, which will return the length of the array. So in this case, we set it equal to 4. A big thing with Java is because you start subscripting at 0, if you want to get the last value of the array, you have to subscript a.length minus 1, because everything is shifted over to the left. Inevitably, somebody who's not paying attention in this class will call a of a.length, and you'll get a Java out of bounds error, and then you'll call me over and you'll say, Steven, why do I have a Java out of bounds error? And I'll be like, you weren't paying attention on September 3rd at 9:48 a.m. When I said that because the length, or because we start subscripting at 0, you always have to subtract 1 in order to get the actual value. So this would be the first element, I guess, technically, but we call it the 0th element. First element, second element, third element. A big thing with Java is making sure that you're subscripting correctly. Okay. This many. Here 4 is called the length of the array, and it is the value of another variable introduced by its declaration a.length. So you can use a.length anywhere in your code to get the actual length of the array. This is really useful for the case, say you want to loop through all the values of an array. You can make a for loop, and you can loop while, or if I guess we like to use while loops here. You can loop while I is less than the length of the array, or a.length. Okay, yeah.
So length is not function that returns the length of the array, or is it? like
Correct.
attribute?
It's an attribute of the array. Yeah. Yes, correct. So you don't need parentheses around the length attribute because it's an attribute of the array. Good question. Okay. Here's exactly what we have here. All the variables get introduced as 0, and then the length of the array gets set equal to 4. Okay. In order to set equal, this is illegal Java code, but this is essentially what Java does every time you declare an array of integers with a size of 4, is it goes through and it sets each of the indices, is what they're called, indexes of the array, to a default value, which is 0. And if you remember, every integer that's contained within an integer array is in and of itself its own integer. So you can treat it exactly like an integer. So going back to, let's loop things together here and go to our GCD example. You could call GCD and pass in the value of a sub 0 and a sub 1 as arguments for the greatest common denominator function. Because these are a sub 0 and a sub 1 are in and of themselves integers. Yeah.
So did you say that like if you declare an integer like a bracket 4, it just prints out an error, like it just won't do anything because there is 4.
This is legal code. You can do this, and then later on in the code, you could say a equals new int 4, but
Yeah.
I just don't see it. The only reason I could see is if you don't know what the length of the array is, and so you want to allocate memory, but it's pretty much always good practice to determine the length of the array before you declare it, because like I said, you can't change.
So you have to declare like the new int, right?
Yes.
Okay. But if it were to say like it ranges to like 4, what happens if it declares like beyond 4? What I mentioned, like it's a bracket 4.
Oh, you like if you subset, if you try to access a sub 4,
Yeah.
you'll get a Java out of bounds error.
Okay.
Because Java will go to where the array is stored in memory,
Right.
and it'll say, give me the 5th element or the 4th integer, and Java will be like, well, I don't have one.
Okay.
And then the it's like a Java lang out of bounds error.
Right.
Yeah. All right. Okay. The other way which you can declare and initialize an array is you can use brackets if you already know all of the values that you want to store within your array. So the left-hand side is exactly the same. You have int in brackets a. The right-hand side, the expression part, is actually the only thing that changes. So instead of saying new int with a value of 4, you can open and close brackets and actually declare what you want to be stored within your array. So 6, 18, 9, and -10 with a semicolon after. What this does is the same as before, but instead of the default value being 0, a sub 0 will be 6, a sub 1 will be 18, a sub 2 will be 9, and a sub 3 will be -10. So it's just another way if you already know the values that you want to contain within your array. Again, a.length is 4, but now the 4 array elements have different values. So again, our little filing cabinet now has files which contain actual values instead of zeros. And this is functionally similar to doing this in your code, but Java does it for you. Okay, so indexing with constants. You may write an int constant. Remember a literal, which is just a literal value c between. I don't know why it says ... That should be 0. Oh, yeah. A sub c, so long as the value satisfies 0 is less than or equal to c, is less than a.length. The important thing here is that it's less than a.length. So in our example here, a.length is 4. So being able to subscript, you would be able to choose between 0, less than or equal to X, less than 4. You would not be able to use 4 as an index because then you would get the out of bounds error. So that's an example here. You could say a sub 3 equals 17. And what that does is it goes to the third value in the array and replaces -10 with 17. Okay. And after the code is executed, we have that a sub 3 is equal to 17. Yeah, so this is what I mean when I say that using the length variable to index the last element in the array, you want to use a.length -1, because using a.length will give you a Java out of bounds error, as the value of a.length is 4, and because we index at 0, there is no fourth element. Right, and so this one takes whatever the last value of the array is and sets it equal to 17. So this is the same as saying a sub 3. And indexing, again, can also use any integer value. So because our GCD function that we wrote previously returns an integer, you could technically access a sub GCD of 2 values. I don't know why you would ever do that, but it's something that you can do. As long as within the subscript, within the brackets of the integer array that you have, that value is an integer. So you can't use doubles. You can't use strings to index arrays. It has to be an integer. Okay. Yeah, here are more Java tutorials if you don't like the way that I explained arrays. Are there any questions about arrays, about static methods in general, about anything? Okay, cool. See you guys tomorrow. Yeah, have a good one.
Steven, where do you find like the Zoom links to office hours?
Yeah. Oh, the Zoom links to the office hours. They're on. They should be on the course homepage. They're not. I'll add them to the course homepage, but they are pinned in the general chat. So if you go here, pinned, all the Zoom links right here, and I'll add these to the Carmen homepage. Yep.
Dude, can I still do the comments?
Yeah.
I didn't get.
For homework, or did you just want us to submit like a PDF?
Yeah. If you want to, you can like take a snip of the code, like snipping to screen capture and input that. Oh, that's fine. Yeah, that works.
But like, I didn't need to submit this up either.
No, just a PDF.
You actually?
Yeah, like the reading really bar ever.
Oh, yeah, no, I've.
See you later.
See ya.
Wait, Steve,
Yeah.
possible to send a meme in advance, like weeks in advance for?
No.
No,
I would not be able to keep track.
like not even if we have a message saying we meme for the week of certain days.
No, it's gotta be that week. Unfortunately. Sit.
That means I gotta wait till like the week of September 14th to send my September 19th.
Set a reminder.
Yeah. I don't need to, I always have a reminder.
Yeah.